Another example for you. Consider the following linear transformation. T maps. Here you have the space into the plane, and it takes each vector in the space and multiply that vector by matrix A from left. And matrix A is given to us as 1, -1, -1, 2, -2, and 3. What is the kernel? So the kernel of T is all vectors like X. You can write it as X1, X2, X3, such that X is equal to 0. So we are basically solving this guy. So here you have 1, -1, -1, 2, -2, 3. And here, as you can see, you have 2 rows and 3 columns multiplied by the column vector down here. And it is equal to, so take a look at this. You have 2 by 3, 3 by 1, and you end up with 2 by 1, 0 vector. Very good. So here you have x1 minus x2 minus 2x3 equal to 0, and you have negative x1 plus 2x2 plus 3x3 equal to 0. You have 2 equations with 3 variables. Two equations with 3 variables. What we can do here, we can basically reduce the matrix. Take a look at this. We have 1, -1, -1, 2, -2, 3, and then 0 and 0. This guy is equivalent to 1, -1, -2, and then 0. Here you're adding these 2 rows together, 0, 1, 1, and 0. If you add these 2 together, this guy becomes 0, 1, 1, and 0. Then you have 1, 0, -1, and 0. So it helps you to solve the problem a little bit easier. Why is that? Now, here you have x1 plus 0, x2 minus x3 equal to 0. So basically, x1 is equal to x3. From the second one, we get x2 plus x3 equal to 0, or x2 is negative x3. So if I take x3 to be t, x1 is t, and x2 is negative t. So basically, this vector is written as, just move this a little bit up here, or let me move these here. So x1 minus x3 is 0, x2 plus x3 is 0, x1 is x3, and x2 is negative x3. This is t, and this is negative t. So the vector x1, x2, and x3 is nothing but t, negative t, and t, or t times 1, -1, and 1. So basically, the dimension of the kernel is 1.